Most discussions of the Korean War focus on movement, advances, retreats, and shifting front lines. But what is rarely acknowledged is how often the war stalled, not because of enemy action, but because materials failed under stress. One of the quietest and, honestly, most consequential failures involved wood. Beams split, supports cracked, and structures weakened not from artillery, but from internal tension locked into the grain. The misconception is that these failures were unavoidable products of climate or haste. In reality, many could have been prevented using knowledge that was already centuries old. During the Korean War, armies relearned, often the hard way, that reading grain direction was not a craft tradition to be dismissed, but a survival skill with strategic consequences. This is a story about how understanding wood at a fundamental level kept structures standing, reduced casualties, and shaped post-war thinking about materials in austere environments. Beams with minor run-out were, reassigned to non-critical roles. Straight-grained timber, on the other hand, was reserved for roofs, bridges, and bunkers. This informal triage extended the life of structures and, reduced emergency repairs. These practices were rarely documented at the time, but their impact was definitely measurable. Local knowledge filled gaps left by modern doctrine. Korean civilian carpenters brought with them a building tradition shaped by monsoons, cold winters, and seismic activity. Their methods emphasized flexibility and, really, a respect for the grain. Military engineers who collaborated with them learned quickly that grain direction mattered more than nominal strength ratings. In some cases, beams were rotated after inspection, not replaced. Simply turning a board so the grain ran favorably reduced splitting under load. This saved time and material, both of which were frankly scarce commodities. This exchange of knowledge was pragmatic, not ideological. It happened because, failure forced listening. The result was a hybrid practice that blended military engineering with traditional woodcraft. These lessons quietly influenced post-war manuals and training. After the armistice, military construction assessments noted differences in structural longevity. Engineering reports began to include language about grain orientation, particularly for field-expedient construction. Manuals acknowledged that material literacy mattered. Reading wood was reclassified from a craft skill to an engineering consideration. For survivalists and preparedness planners, this shift is instructive. When industrial supply chains fail, old knowledge becomes current again. Grain reading was as much about risk management as craftsmanship. No builder in Korea had the luxury of perfect lumber. The goal was not flawlessness, but informed compromise. Builders learned to predict how a beam would fail and to avoid configurations that turned predictable weakness into sudden collapse. This approach reflects a broader wartime mindset. Grain reading was one example of a larger principle. Materials have behavior, not just specifications. Structures that endured did so because someone took the time to observe before acting. The consequences of ignoring grain direction extended beyond inconvenience. When beams split in occupied structures, the results could be severe. Collapsing roofs endangered personnel. These were not dramatic failures that made headlines, but cumulative ones that eroded readiness. Over time, the cost of ignoring grain direction became undeniable. The Korean War demonstrated that small technical decisions, repeated across thousands of structures, shape strategic outcomes. Today, kiln-dried graded lumber creates the illusion that grain no longer matters. In disaster zones, remote locations, or long-term preparedness scenarios, it is not. The old ways of reading grain direction remain relevant because they address uncertainty. They reduce dependence on external systems. The Korean War serves as a modern case study of ancient knowledge reasserting its value under pressure. Remembering these overlooked lessons matters because history is not only about decisions made at the top. Understanding how grain direction prevented split beams during the Korean War reminds us that endurance often depends on respect for fundamentals. If you value this kind of in-depth, material-focused history, where survival, logistics, and overlooked knowledge intersect, consider subscribing to the channel. Share this video with others who believe that understanding the past means paying attention to the details that kept people alive and structures standing.